So this recording is just for more support in terms of understanding the three processes that happen in the nephron. Usually I get you to work in a group and make a big nephron and do this on a big scope as a group, and then also do your own for a study tool. Sometimes we run out of time and may not have done that quite to the extent that I like. So I'm just going to do this video in case you want something else to walk through or kind of remind you of what happens within the nephron. So let's see. Along the top, I've included sections to show where certain processes happen. So the first process that happens is filtration. The second big one is reabsorption, and the third is secretion. I'm hoping you can see this mouse and cursor whenever it's moving, but anyway, basically, filtration happens between the glomerulus and Bowman's capsule. So in this first part here. So if I take the pen, let's see, we go with a funky, there we go. Now this diagram, if you wanted to find it, is linked already from the class notes page. If you go to the class notes page, it's called, I think, Nephron and Skin Diagrams. If you click on that link, then you'll find this diagram as well as the skin diagram. Okay? So basically, your blood comes in from the renal artery, and then eventually it'll come in through the afferent arteriole, if you can see, and then into the glomerulus. Really super high pressure there because it's feeling the pressure from the heartbeat, but it's also all, the blood vessels there are all coiled up, and they're porous. So it's like a high pressure, it's going to push out whatever will fit out through those pores. Okay, what's left in the blood is going to continue out through the efferent arteriole, efferent meaning away from, okay, and head towards the branches of the capillaries, the peritubular capillaries that'll actually surround the nephron, although we don't see them here. We haven't drawn them in because it gets a little confusing when you see them all there at once. So, of the things that are forced out, we call whatever is forced out into the Bowman's capsule, we call that the filtrate. It might be the nephric filtrate, or it might be the glomerular filtrate, but it's the filtrate, the stuff that's been filtered out. Let's see if we change pens now. So of that material, some of it is just going to keep on going out and be excreted in your urine, but some of it is stuff that's useful to the body. Depending on what your body's situation is at the time, you may need more of certain things. So this first section right after Bowman's capsule, the proximal tubule, is the first chance for us to reabsorb or take back in useful materials. Okay, so some ions, like there might be a bit of sodium, other ions that are going to be reabsorbed here. But glucose, if your body is in need of glucose, it's going to be reabsorbed from the proximal tubule up to what we call the threshold level. Now, the threshold level is kind of like a, if you think of your thermostat, then it tries to keep the temperature at a certain level, level that has been set. So the threshold level for any substance is a level that it helps to maintain homeostasis or normal level in the body. Okay, so glucose will be reabsorbed, amino acids will be reabsorbed, some ions will be reabsorbed, and a bit of water will be reabsorbed from the proximal tubule. Now, the rest of the material is going to move along in through the loop of Henle. And so we have a descending loop, and we have the ascending loop in the loop of Henle. The ascending loop has a thicker part because in that part, we have a lot of active pumping going on. So to pump things against where they'd like to be, it takes a lot of energy and mitochondria to give the energy and lots of things like that. So it tends to be thicker because of what's needed in the cells around the outside of that tubule. What happens here, it's looping down into the medulla, okay? What happens here on the ascending side, we're actively pumping out sodium. And chloride will follow, but we're actively pumping out sodium to make the medulla, this part of the medulla, really salty. So all this area out here, and out here, and out here, it's all going to be salty. So it's, if you remember, we talked about some terms last year. Um, we talked about hypertonic and isotonic and hypotonic situations. So it makes the surroundings, what's outside of the nephron, really hypertonic, meaning there's a whole lot of stuff that's out there, a whole lot of solutes, a whole lot of salt in this case. And water tends to like to move, when it's free to move, it tends to like to move in order to balance out the concentration. If it's hypertonic, the water's going to move into that area in order to try and level out the concentration. So by making it salty out here, we're drawing water out of the descending loop. Okay, the descending loop over here, this side, is permeable to water. So water is actively going to not actively, but passively going to move out to where it's salty to try and balance out the concentrations, and then we'll reabsorb it into our blood. Okay, so it gives us a way of trying to reabsorb most of the water that is filtered out. So by the end of the loop of Henle, most reabsorption has taken place. Okay, so most reabsorption, if someone were to ask you, what sections of the nephron most reabsorption happens in, it'd be the proximal tubule and the loop of Henle. If they asked where most water is reabsorbed, it would be in the loop of Henle, okay, and specifically the descending limb of the loop of Henle, okay. So what happens next? Well, we move the whatever's left in nephron is going to pass along into this region up here, which is the distal tubule. And it's usually, both the proximal and the distal tubule are usually convoluted, meaning curvy. We haven't drawn it as curvy on this one, just so it's a little easier to see what else is going on. But it is also found in the cortex. Okay, so the Bowman's capsule, the proximal tubule, and the distal tubule will all be found in the outer region of the kidney. The loop of Henle drops down into the medulla and makes it salty down there. So what happens in the cortex? Well, this is, what happens in the distal tubule? This is the last section. I don't know if you remember the little demo that we did in class, but it's that last section, last chance before we get rid of the wastes and stuff. It's the last chance to add any more waste that we couldn't filter out. Okay, so this process is called secretion or tubular secretion. It requires energy because they have to actively push things out even though they don't want to be. So things like, they're shown with the blue arrows here, but things like creatinine, drugs, and hydrogen ions. If the blood's acidic, hydrogen ions will be forced out too, and that's how we can help regulate the acidity of the blood or pH levels. I'm not sure if you can hear my little fellow in the background, but he's trying to tell me he finished his grapes. Oh, Nene got you more grapes. Awesome. If nothing else, you get a little chuckle while you're watching this video. So anyway, this last part of the nephron is where we can get rid of those last chance to get rid of those wastes. Okay? It's also a region where, depending on your body's situation, there might be some special reabsorption going on. Okay, and I'm saying special because it's only going to happen under certain conditions and only if certain hormones are present. Okay, so they are indicated here Green arrows are showing all the reabsorption that's happening. Okay, but these ones are indicated with a little star to the left of each of the things that are being reabsorbed. And in brackets, it's indicating which hormone. Okay, so if PTH is present, so parathyroid hormone, then calcium is going to be reabsorbed. So if your body's needs aren't being met, you don't have enough calcium coming in your diet, then it might trigger the release of this hormone to make sure that you reabsorb whatever you can from your kidney. Okay? If your fluid levels are low, okay, we had that whole schematic diagram. Your hypothalamus is involved. It detects that the fluid levels are low, and it causes the release of this hormone, ADH. And ADH comes to the distal tubule and the upper collecting duct and says, hey, we need more water. So it causes it to be permeable to water. Normally it's not permeable to water, but in this case it would make it permeable so you can reabsorb that last 15%. Okay, so if that's going to be reabsorbed, it means there's not as much water going out in your urine, so your urine's going to be darker because you're not getting enough fluid back into your system. Okay, the last one is if aldosterone is present, then we'll reabsorb sodium. Now, we talked about this with the other schematic diagram. Okay, aldosterone is released when your blood pressure is low. And the reason for it is whenever the sodium is reabsorbed, we know what always follows sodium, just like out here, okay? Water is going to follow the sodium and be picked up by your blood, okay? So when the water goes in, it increases the blood volume and therefore increases your blood pressure. So these cases of reabsorption out here that have the green and they have the stars by them and they have the hormones indicated in the brackets, they are special cases. Otherwise, whatever else is here is going to be, is going to be excreted out in your urine. So listed hydrogen ions, drugs, creatinine, urea, uric acid, and if there's excess items that your body doesn't need more of, then that'll go out in your urine too. So sometimes, if you've had a really big meal and you have way too much glucose, sometimes you might have some glucose appearing in your urine, okay? But that is kind of an overview of what happens in the three processes. And if you did not get to finish doing your study tool, then hopefully this will help you to finish yours up or help you to make more sense of what you have. Remember, if you have any questions, please email me anytime.